So far this year, we've learned about what are called linear equations, which are lines, and we've learned about exponential equations, which are curves. And we're about to hop into our third type of function that we learn about in this class, called quadratics. So those of you who are in my classroom know that there are three graphs on the back of the wall. There's a line, a curve, and a U. Well, a quadratic is that U-shaped function. So that's what we're going to be talking about today. We're just going to spend today talking about vocabulary because there's a lot of vocabulary involved in a quadratic function. The whole first page of these notes is a bunch of definitions, and on the inside we're going to be labeling a parabola just to make sure we know where all of these vocabulary words exist when we use them. So a quadratic function is defined as a nonlinear, so curvy, function containing an x squared term as its degree. So no bigger, it's not going to be like cubed or anything, but it has to have an x squared term in it. The shape that it makes, that U-shaped curve, is called a parabola. It looks like parabola, but it is pronounced parabola. Now, when we get into the different parts of this function, of this parabola, it has what's called a vertex. The vertex of a parabola is the highest or the lowest point. It's not going to have both a high and a low point, but the highest or lowest point, also called the turning point of the parabola. It is a coordinate point, and we give it really special letters. We give it the letters of H, K. Why it's H and why it's K, I actually don't know. I might Google that before class, but it is H, K. The axis of symmetry, just like the way that it sounds, is the invisible vertical line that splits the parabola into two symmetrical pieces. Okay, so you have that U-shaped function. That axis of symmetry is going to like cut it right in half. The function for this, since it's a vertical line, is always x equal, and it's the x value of that vertex. So x equals whatever h is, whatever that first number in your coordinate pair is. The next vocabulary word we're going to discuss is the zeros of a function. We've kind of talked about this word already at some point this year. But the zero of a function is always going to be the number that the value is when it crosses the x-axis. Okay, there's like a bajillion words for the zero of a function. You're going to hear me call them all of them. You're going to have to memorize these ROX words. ROX stands for roots, zeros, because, you know, an O is like a zero, the x-intercept, and the solution. Those are my ROX words, and that is going to be what I'm asking you for when I ask you for the zeros. I'm going to say zeros, but if you want to think x-intercepts, that's totally fine. If I ask you for the solutions and you want to think x-intercepts, that's totally fine. All of it is where the graph crosses the x-axis. Now, y-intercept, where the graph begins on the y-axis, is where the graph crosses the y-axis. It's always going to be 0, some number, but we're actually going to start calling this number c for where the graph crosses the y-axis, the constant. Now, these graphs have either a maximum point or a minimum point. The ones that look like hills, the top of that hill right there is called the maximum point. Top of the hill. That's not an official math term. That's what we're going to call it. The top of the hill is a maximum point. And you guessed it, the bottom of a valley is a minimum point. When you think of maximum, it has a word max in it. Think big, maximum, top of the hill. When you see mini, you think small. So you have to think small, low, bottom of the valley. Now, not only am I going to need to know the maximum point and minimum point, sometimes I'm going to be asked for the maximum value. So that maximum value is the y value of that maximum point. Basically, you can think of this as the highest level. How high does it go? That's its maximum value, the tallest that it gets. The minimum value, again, is not the coordinate point, but it's going to be the y value of that minimum point. Or think of it as the lowest level that this graph goes to. As low as it goes, as small as it goes, because it's minimum. what is that level that it goes to? Now the last couple things are a little bit extra here. We have a positive x value and a positive a value and a negative a value. A positive a value graph is a graph that is smiling because it's happy. So this is what it's going to look like. It's smiling. We would say that this opens up because you see how the arrows are going up. It's opening up. It's smiling. Now a negative parabola, sad parabola, it's going to be frowning. A frowning parabola, and since those arrows are going down, we say it's going down. So it can either be a happy parabola or a sad parabola, depending on what the a value is or what the very, very beginning is. Either positive x squared for a smiling graph or negative x squared for a frowning graph. Domain and range we have defined a million times over this year. Remember that domain is the x values where the graph shows up, and the range is the y values where the graph shows up. Now for quadratics, it's actually pretty simple. Domain is usually all real numbers because usually these graphs go on forever in both directions. There will be times where it's specifically stopped, but remember you're going to have to look for those endpoints for that to be the case. Otherwise, when it's going both directions, it's all real numbers because it's never going to stop on the right or the left. But the range is going to have two options. It's either going to be all of the y values that is below the value of k from the vertex, or all the values that are above that value k of the vertex. So less than or equal to, remember, is below, and greater than or equal to is above. So is it all above the minimum point, or is it all below the maximum point? That is a lot of vocabulary. Let's pop in on the inside and see if we can digest this information. On the inside here, we have the first graph. It wants us to label the following for a positive x squared graph. So we have a smiling parabola. It would be opening up. First thing we're going to label is the vertex. Well, the vertex is the turning point, or the smallest or highest point. So the vertex is right here. That's your vertex. The next thing it asks me to label is the axis of symmetry. Now remember, symmetry means it's two equal pieces. So I need to cut this right in the middle, right on that vertex with an invisible vertical line. We make it dashed to show that it's invisible. And it cuts right through the center. That's the axis of symmetry. If I were to fold this parabola on that line, they'd fit right on top of each other. The next word is the root, also the zero, also the x-intercept, and also the solutions. Since my rocks word, R-O-X-S, rocks, are all the same place, we're still just looking at where this graph crosses the x-axis. The roots, zeros, x-intercepts, and solutions, there's two of them. All of those words are at the same spot, so don't get confused. All of those things are the same. Your y-intercept is where the graph crosses the up and down axis, or the y-axis. So right here is my y-intercept. The next word is the maximum point. Now, maximum means the tallest point. Does this have a tallest point up here? No way. There's no tallest point. You've got arrows that go up. So we actually don't have a maximum point or maximum value. But we do have a minimum point and a minimum value. The minimum point is still right here at my vertex. That's exactly where the minimum point is. And the minimum value would be whatever this value is on the y-axis. We look over at that level and we say, well, how tall or how small are we? Now it's going to be your turn. On the next graph, I want you, for the negative x squared graph, I want you to try to label all the things. When I unpause the video here, so when you press next, it is going to all be there for you. So make sure you pause the video and try it. How would you do on labeling? Great. Remember, my axis of symmetry and vertex and maximum point here are all at the same coordinate right here, cutting it in half. My maximum value is the height that I get to. All of my rocks words are where the graph crosses the x-axis. Forgot to put my little dots right here to show the coordinate point, and my y-intercept is where the graph crosses the y-axis. Great. Now, not only do we need to just be able to point at the parts of this graph and say that is the vertex, on the next side, we're going to actually have to name the vertex, the axis of symmetry, the zeros, the max and min, and the domain and range. So more than just pointing at it, let's talk about how to answer these exact questions. For number one, if I asked you for that vertex, you know that it's the turning point of the graph, so you could say it's right here. But remember, I answer this as a coordinate. Well, that's the coordinate 2, -4, so that's my vertex. That's going to be my h and my k. The axis of symmetry is going to have to cut that parabola right in half through the vertex. So it's a vertical line right there, but the actual axis of symmetry is a vertical line. It's a Vux line, starts with x, and it's actually going to be equal to 2. That's h. X equal 2 creates my vertical line that cuts this in half. Now my zeros, notice this time it didn't ask me for all of the rocks words, just the 0. But we know that the zeros appear where the graph crosses the x-axis, right? Those are my rocks words. So it appears at 0 and 4. My y-intercept is where the graph crosses the y-axis. So I actually think it crosses at the same part as one of the zeros, and that's okay. It's the coordinate 0, 0. This next question asks for a max or min value. Well, this doesn't have a maximum, but it does have a minimum, and its value, or its height where it's at maximum, is -4. That's the lowest. I think I said maximum a second ago. I meant minimum. That's the lowest that this will go, is -4. Now the domain, since it will never stop on the left and never stop on the right, is going to go to -infinity and +infinity. And we know that when you add double infinities, that my domain is all real numbers, meaning it never stops on the right or left. The range, however, is really interesting. I'm going to draw a dashed line on here that doesn't really exist, but it's just to help us visualize here. Okay, so you see this boundary I'm putting in there? Would you say that the whole curve, the red curve, is all above or below that dashed line in black that I just wrote in? I would hope that you said that the whole graph is above that value, and that minimum value is -4, which is the value of my vertex. The vertex contains a ton of work here. Now we're going to do the same thing. The questions are going to lead you through the different parts of this function, so go ahead and start looking at this number 2 and answer the questions as you go. All right, how did you do on this one? We've got our vertex right here. That's the coordinate -1, 8, which means my axis of symmetry is the vertical line x equal -1. My zeros appear where the graph crosses the x-axis. That's -3 and 1. Y-intercept is where the curve crosses the y-axis. That's 0, 6, the coordinate. It has a maximum value, not minimum value, and that max value is 8. That's as high as it goes. Its domain never stops on the left and never stops on the right, so its domain is all real numbers, but its range is all below that value of 8, because the whole graph appears below the value of 8. We said that's its maximum value. Quadratics really have just a ton of vocabulary in them, so we need to make sure we understand this vocabulary when we come to class. We're going to spend a ton of time on this, just making sure you know all the parts of a quadratic, because they're really, really cool when we get into what they represent in real life. But you got to know this vocabulary. Take your time and learn it all. We'll see you in class.